So how does DMA do its magic? As you configure your DMA, you set up a pool of resources, and those resources will be coming from multiple RMX or Codian bridges. What happens when someone initiates a call, they'll request certain levels of resources, and when that request comes in, DMA compares that request to the available bridges that are online and can take a call at that time. Whichever bridge is least being used and fits in the pool requirement will be given the conference. That pool requirement could be a geographic requirement, meaning if we had a bunch of people in Europe attending a call, it would seem silly and wasteful of bandwidth to have them call into the US. It would be better for them to call a centralized bridge, possibly in Europe, and then do a cascaded call, single call back into the US. Those are things that DMA can set up and help you do. Now, if everything is equal, DMA will use a least used algorithm, and if all those are equal, then he'll just round robin and pick the next available bridge. Okay, very simple algorithms, but it works very effectively. Let's look at how superclustering and supernodes work together. Here we have geographically dispersed across three areas, the Americas, Eastern Europe, and then the Far East. In this case, all the calls would be coming in for the Americas into Austin. Now, if for some reason that Austin bridge were to go down, or that Austin, one of the bridges were to go down, then it is very likely that the DMA in Austin would select one of the bridges in Europe, because when the US is awake, typically Europe is asleep. Equally, if Beijing loses one of their bridges, then they'll turn around and most likely use one of the bridges out of the US, because the US is probably asleep when Beijing is active. Anyway, so you can see in the yellow lines indicate backup territories or backup bridges, and the green are the primary territories. Clustering can be set up fairly easily, though it does take a very good understanding of the overall network topology being used. Some of the terminologies we've used here on DMA, a user, local or enterprise user. Now, enterprise user, what's an enterprise user in this case? In this situation, that would be a user whose information has come to us through Active Directory. DMA works very nicely and interops very well with Active Directory. In fact, in many cases, it allows us to automatically build virtual meeting rooms based on Active Directory information. The next item, the virtual meeting room, is very similar to an RMX meeting room, where it's a spot where we have a definition of how big and how many sites are going to be in it, and what the layout, whether it's Hollywood Squares or voice activated or whatever it may be, possibly recording even. And the virtual meeting room will define what the conference is. Now, where do we get the numbers for the virtual meeting room? Oftentimes, we'll end up using the phone numbers from the Active Directory coming to us from the enterprise to build those virtual meeting rooms on demand or as required. A site, it's a network location defined by subnet used by a call server. So since we now have a call server, we have to start defining what that worldwide, potentially worldwide network looks like. And so we have to define the sites in that network. RMX or MCU, we've already discussed, is a bridge. Pool is a logical group of MCUs, whether they be Polycom or other manufacturer, meaning Codian. A cluster is one DMA system, single or dual server. Okay, and a supercluster is up to 5 DMA clusters, and as I've mentioned, they can be geographically distributed around the world. A territory is a collection of sites that a cluster is responsible for, or who he owns, or who he will respond to as calls are required of him. Let's look at the call server functions that are now being provided. These are shared across the supercluster and apply to all clusters. Now, one thing I didn't mention about superclusters is they automatically communicate to each other. There's no master and no slave. So when a new cluster or a new comes into the supercluster, he is automatically communicated to and brought up to speed, and his information is shared around, as is everyone else's information is shared with him. Okay. Well, some of the things in the call server settings, gatekeeper, typically 323, whether we're going to run direct mode or routed mode. And these are all really parameters that go down through the gatekeeper setup for the DMA. Also potentially some of the other setups, maybe some of the SIP setup information that might be required. Some of the other gatekeeper function, 323 gatekeeper functions that come with DMA, address translation. That's one of the key features of a gatekeeper. It allows you to take an E164 or an alias and allow that to come back and become a real IP address. It also has a CAC, or a call admission control capability, so he can limit who can take a call or who cannot take a call. He also is a bandwidth administrator. So if you haven't gotten enough bandwidth available for the whole call, the DMA gatekeeper will actually ask the endpoint to downspeed his call if there is any bandwidth available. Okay. Some gatekeepers are very binary in that if there's not enough bandwidth, if you ask for a meg and there's only half a meg, he'll tell you a meg of bandwidth is not available, and he'll hang up the call. CMA, DMA, most of Polycom's product lines are very advanced in that they will step down and ask for less bandwidth from the endpoint, and typically they can get it. It also controls call routing, whether you're in direct mode or routed mode, zone management, where you're controlling many endpoints. We also have some forwarding capability, so if you're busy or you're not at your desk, you can actually have the calls forwarded on to another endpoint. And we do have hunt groups, which are similar to an ACD, but not quite as extensive as an ACD or an automatic call distribution system would have. But the basics are there. Bandwidth management. As I mentioned, we have the ability to limit how much bandwidth is between two sites, and that can be very important. Let's say you only have a T1 with 1.5 meg. You don't want people running 2, 3, 4, or attempting to run 2, 3, and 4 megabyte calls across there. So we do give you the ability to set up sites and limit the bandwidth within those sites. We also have bandwidth prioritization. One of the things we've added is a bronze, silver, and gold capability, where someone with gold capability, if they need bandwidth and there is no bandwidth going to a specific site, and there are other calls going on at a silver or bronze level, DMA will actually disconnect enough of those sites to give that gold user the ability to place their call. We sometimes call that the general's call, meaning he has priority over most everyone else. And when his call needs to go through, we'll do everything we can to get it through there. Now, we also have the ability, working with our Juniper partner, of doing some bandwidth assurance. It allows us to make sure that the bandwidth is available and crosses with priority all the way through a Juniper-defined network. It does work it does work with Juniper only at this point in time, but it is a good way to set priorities all the way across your network. Bandwidth limitation is one of the key features of a gatekeeper. It has the ability to control that bandwidth for the endpoints and make sure certain systems don't take over and use all the bandwidth. We do only manage the video side of the house. We do not manage the IP or data side. So we're only looking at the bandwidth that video calls will be taking up across the network. But that's something that certainly the gatekeeper in DMA can help provide. Registration history gives us the ability to see who's registered and to help troubleshoot if we are seeing issues with sites trying to register into DMA and into the call server. DMA also has a SIP registrar and proxy function capability. It is full RFC 3261 support. Endpoint registrations can be seen in the network endpoint section of DMA, and allows you to look at all those endpoints that are registered and set up in the system. You can do SIP endpoint registrations can be restricted by domain. So if you happen to be in an environment with multiple domains, you can limit those registrations to only the domains that you want in your network. You have the ability to view active calls, whether they be 323 or SIP calls, in the DMA administrators page. It's a very easy way to see how much bandwidth is being used, what kind of systems are in the calls, how many calls may be ongoing at any one time. You think about a supercluster environment where I have literally thousands of endpoints. This can be an important area for the operators to maintain and monitor to make sure everything's going on well. Of course, we provide a call history, or a CDR, call detail report of all the conferences that have gone on, both SIP and 323. They can be exported fairly easily into CSV or comma separated value files, and allow you to import them into your favorite database or Excel spreadsheet for processing. Some of the conference manager functions, and we've talked a little bit about this. DMA conference room, another name for it is the virtual meeting room. Virtual meeting rooms are defined on the DMA and are typically associated to a user. Okay, may be associated by his phone number, may be associated from his employee number, whatever unique number they happen to choose within the company's design or dialing plan design. Every virtual meeting room has its own attributes. It gains those attributes from templates, and those templates can be customized at any time on the DMA. One of the handy things is we keep those templates on the DMA. That way, no matter what bridge we're talking to setting up a conference, DMA automatically sends the requirements along with the conference setup to that bridge. So the bridge doesn't have to know anything about what's coming, because he'll be told on the conference setup exactly how to set up the conference. Some of the conference settings, here are some of the system-wide settings. Maximum number of endpoints may be 5. Some customers don't need a whole lot of endpoints set up in their bridge, but they may have many, many small conferences. One of the larger companies I worked with, they only had at that time, about 140 endpoints around the world, and we rarely had a bridge call more than 5 sites, but we'd have 10 or 15 of those bridge calls going on at any point in time. So it was rare that we had a really big call, but we had a whole bunch of little ones going on almost all the time. Okay. Here in the template, as I mentioned, is where you actually set up your conference configuration, how you want the conference to look and feel. By having it on the DMA, we've eliminated one of the areas of contention with the RMX, where the RMX initially held the profile, and we had to go to every one, in this case 3 RMXs, and make sure all the profiles were exactly the same. That can be a problem, especially if we're having a mechanical issue and we're replacing one of the RMXs. Then we have to go back in and make sure they have all the right profiles. So we've elected to push those profiles back into DMA, so as DMA starts to call, he sends that profile information right back out to the MCU at the start of the call. That's about it for DMA. That's a real quick overview on DMA, and I hope that was helpful for you. Other resources are certainly available on the Polycom website. That would be the DMA version 4.0 release notes and the operator's guide. Thank you. Hi, I'm Gary Miyakawa. We're here to talk about the RSS 4000 recording and streaming server from Polycom. This device is designed to sit in the back room and record video conferences such as what we're doing right now. In fact, we're using the RSS 4000 to make this recording just so you can experience its capability and its quality. The RSS 4000 is a network accessible IP video conferencing recorder designed to look like an H.323